So data lakes and lake houses, common use cases that we see across, and this is not a complete list, but this is kind of like the common use cases I've seen and that we've seen at Absolver with our customers and within the industry. So on the data lake side, again, being a central repository for your data, very commonly you see it used for archiving. So you want to archive your raw historical data. Maybe those are CSVs that are coming from databases, mainframes, IoT devices sending a lot of data, security logs. You just want to put it in an object store so you can archive it, you can maintain it, you can audit it later, but it's the historical data. Maybe in 10 years down the road, you want to bring it back out and you want to do something with it, you can do it there. Doing that inside of a warehouse will cost you significantly more, and it's not an ideal situation. So that's where you want to put it inside the lakehouse. Tiered storage. Data lakes are often used as a way to tier storage. So if you see technologies like Spark and Flink, for example, where they maintain a lot of the data they process in memory, but when they need to flush the data, they flush it into the data lake because it's kind of like a scratch space, a way for them to store data in a highly scalable way and be able to then pull it in when you need it. There's databases like Lakehouse, Snowflake, some of those tools where they actually allow you to bring the hot data into the database itself. So you can query it, but the warm, cold data can sit in S3 and you can then query it that way. So you're saving yourself money by keeping the cold, less query data in S3 and only the hot data, highly used data inside of the engine. Unstructured data processing. We didn't talk a lot about it in analytics, but as you start talking about LLMs and Gen AI and some of those things, there's lots of unstructured data, PDF documents, even HTML documents that aren't fully processed, images, videos, things like that. That's an important aspect for you to think about as you're bringing that stuff into your data platforms, right? So data lakes is a great way to solve that. ML model training. So as similar to unstructured data processing, now that you process that unstructured data, the images, you want to train it. To pull the data out of a warehouse and then train it, or to train it on top of the warehouse, could be costly, could be slow to do. So it's much easier to do it from the lake. And then cross-cloud sharing is really powerful model to say, like, if I can just take my data in Parquet format and JSON, I can just save it in GCS and then copy some stuff over to AWS if I want to run some analytics there, right? So cross-cloud sharing is really, really easy to do in a data lake. Flip to the other side of the lakehouse, very similar use cases to what you'd see in a warehouse, but applied to a data lake. So BI, ad hoc, and interactive analytics. Now I can run queries to my dashboard, to my notebooks, through my, my SQL workbenches. It's a lower cost warehouse alternative. If I wanted to leverage a query engine like Trino or Presto or Starburst or Dremio or Amazon Athena, I can use those tools at a lower cost than fully buying into a warehouse and be able to still get the same capabilities of updating and deleting my data in the lake, optimizing query performance, managing my schemas, and things like that. So think of it as kind of a lower cost warehouse alternative. So similar to that, warehouse cost reduction and tiering. Again, you can move data into cold storage or colder storage in Iceberg or in the Lakehouse, and then still query it from Snowflake and BigQuery and Redshift and all those warehouses. Database replication. So if you wanted to take a Postgres database and fully replicate that into your lake, Lakehouse gives you the semantics and the abstractions to be able to do the merging, right? The updates and the deletes into the lake, where in a data lake, that was a lot harder to do. Now you can do it very easily with this Lakehouse abstraction. And of course, cross-cloud sharing, as you'll see throughout the presentation, this makes it very easy for you to sort of write data in one cloud and easily access it from a different cloud or move it over to a different cloud. That cross-cloud is super, super important aspect as you start scaling out your data platform, as your company grows and want to kind of leverage the best of each cloud has to offer.